Okay, so today's we're going to see instruction set architecture. Okay, basically it is a this instruction set architecture is come in your second unit. So what is instruction set architecture? Okay, basically in simple word, the instruction set of computer specifies the primitives, commands, or machine instruction that a programmer can use for programming the machine. Instruction set architecture defines set of operation. Instruction set of architecture is used to define set of operation. Instruction format, hardware supported, data types, storage, addressing, mode, sequencing, and extra. One of the important property of the complexity of instruction set is attribute to the instruction format, data format, addressing mode to be used, type of general purpose register. Okay. Further instruction is an abstract interface between hardware and lowest level software of machine. Okay. So you can say that in here in diagram you can see that software and hardware instruction is architecture interface, that is the software and hardware you can see in this diagram, right? Okay, so that is a most important abstraction is a critical interface between hardware and software, like this example you can see. Okay, so describe the properties which is follows, so which is basically address from software side, efficiency which is basically address from hardware side. Okay, means something property that is belongs to software and something properties belong to your hardware. Based on the experience in process design, there are two categories of instruction set architecture has been involved, like complex instruction set and reduced instruction set. One of the complex and another one is a reduce. So in this diagram you can see, right? So here like in complex instruction set, like in instruction categories having load means you can store, then jump and branch, floating point, spacious memory management, all are there, right? So important of numbering here, just 1 minute. So here you can see that this one. Okay, so in this diagram you can say output register, then function is are there, right, in instruction set architecture. So here notation also given, means how the 64 bit represent in this form, how 8 bit represent in this form, and after 8 it here after 8 bit is show in dark line, right, then after again 8 line. Okay, is 64 bits, you have it directly 64 bits, say 8 bits, then two words, means this one, and after this two words, and one double words, that this one all. Okay, so these are the notation for information representation. Then next here you can see numbering of the various unit of information is consists of manners. See, you can see here, this is the most signification, that MSD we have seen most signification and least signification in our previous lecture. Numbering or representation in we have seen in this lecture, right? So most representation means here mention here that big end, like see here 9 say end or IO, right, that is a big and that is the most MSD, most signification digit, and this small end here least significant, that is a little end here is 6 is little here, that's why least signification. Okay, then big end numbering is start from 0 to 6, and least numbering start from 0 to 6, like this. Okay, these are the instruction sets diagram here there. So numbering, in order to understand the concept, remember that in English text is written left to right, right, and character are numbered left to right in order. Further, numbers can be numbered in two different ways for specific purpose. Further, each memory location are number are called address. Location को हम address बोलते हैं. Okay, here the result of consequence of numbering teaching, such as Data is stored in memory according to byte numbering, where the lower number byte goes into the byte in memory with the small address. Further, data is sent through a bit serial communication channel according to bit numbering. When displaying computer representation of human, such as number are written in the use MSD, that is most significance, on left, and LSD on right, least significance. And the corresponding text is written in such a way as to match numbering of numbers. Okay. So these are the um, related to the instruction set. Okay. Then now we will see here this one. Okay, alignments of words in memory. Basically, according to the data CPU axis, a 32-bit words of data starting at byte address, that is x to x00, where such an address is of multiple of byte 32, 8 and 4. Okay, 32, 4, 8. एंड इज कॉल्ड वर्ड अलाइनमेंट, मतलब 3284 इस बाइट को हम वर्ड अलाइनमेंट कहते हैं. अनदर इंपॉर्टेंट पॉइंट इस मेमोरी कंट्रोलर इज सिंपल एंड फास्ट. मेमोरी कंट्रोलर इज सिंपल एंड फास्ट है. डेटा अवेलेबल इन वन साइकिल. ओके, according to the above discussion, CPU axis 32 bit. Okay, CPU axis 32 bit word of data starting at byte address, that is byte address क्या होगा 011 0 to 4 times 1, where the byte address are 04 times 1 10000 1001 10010, right, like binary number, double the access time of word. According to the above axis criteria, requiring aligned address result in simple memory control and faster execution, cause some loss of storage and adds complexity in code generator. Right? So these are the alignment of words here. This 3284 bit is described here, right? See, this is a memory control, right? Memory bank here. These are there. Now, sub word axis here. This diagram is sub word axis. In that case, byte operand in register is usually the rightmost byte of register, and the byte may come from for memory bank. जो बाइट है ये फोर मेमोरी बैंक से आती है. ओके, so following are the needs of routing hardware, which can be either at memory side of bus, where byte always travel on rightmost of bus, or CPU side, where the bus lanes are extensions of memory bank lanes, and the source of complication can occur in the either side. मतलब memory कहाँ से occur होती है, किस side से होती है, this type is given in this subword access machine or mechanism. Okay, so here objectives are there, like code size you require. Code size means which depends on following factor, like such as cache memory, access time of cache, on chip, off chip, CPU bandwidth you require. Frequently used instructions should be short, implies variable length instruction, but there are negative to this. So here objective is there, that is a speed or performance. Here object is given, that is first objective में code size require होती है आपको इसमें. Objective 2 में speed or performance, like where only frequently execute instructions should be included in the instruction set, which are infrequently execute instruction slow down the other, where the complex and long instruction tend to be used infrequently. Also define hardware software interface. Further, frequent execute instruction should be fast. Pipeline should be made as easy possible. Okay, then objective third में क्या होगा, which minimize size and complexity of hardware, like ALU. ALU we have studied in first lecture of computer organization in detail. So in third objective में minimize size and complexity of hardware, ALU controller. Also implementing infrequently execute instruction. Then objective 4 में क्या होगा, there are many situations where instruction set as programming language can be used. Okay, for objective 4 में programming language we require also need to human programmers, less important today. Further, several described properties of instruction set have been recognized and described, such as orthogonal, where each operand can be specified independently. Other and need of optimized compiler. You know, compiler, the work of compiler. There are also simple instruction are more suitable for code optimization. For optimizing, compiler are try to find the shortest or fastest code sequence that implements this you can say HLL program. For that, make code recognition. Okay, so compilers work. Then here, just 1 minute. We require the memory organization here. Okay, this over here our 1 minute. Memory organization we require. So in memory organization, क्या होगा उसमें location, we require capacity, then unit of transfer, access method, performance, physical type, characteristic, and organization. So what is memory hierarchy? Okay, so first we have to know about the hierarchy of memory. So let me show you it. So here it's not there, this one. Okay, memory hierarchies में कौन-कौन से components लगेंगे? Hierarchies of CPU register will require CPU register, right? Then cache memory, right? Then main memory, then magnetic disk, then cache memory, magnetic disk, then require optical disk. ये आपको एज ए हायरार्ची में शो करना है. ओके, I don't have here now diagram, so I'm showing you like this. Then magnetic tap, sorry. Okay, just 1 minute. So just आपको क्या करना होगा hierarchy में, you have to just mention this all in middle. Okay, then the in box you have to mention this all. Then you have to write here speed increase as an internal memory and extra memory. Wait, let me show you here. Okay, so after this you have to write speed increase as speed increase. Okay, and next we require again here, that is it is a hierarchy. Okay, I'm just showing you like this. Just आपको यहाँ पे box बनाना होगा, either CPU after again box cache memory, main memory, यहाँ पे internal speed, then यहाँ पे आपको लिखना होगा inter, then you have to write just inter. Let me write first. So see, so आपको जैसे ये mention करना होगा, this is the your hierarchy of memory. Okay. And so here I said that there are many external units in computer form, which is the memory unit in an essential component in digital computer. The memory hierarchy system consists of all storage device in computer system, from the high capacity then to relative for the faster main memory. Therefore, it is a more economical to use low-cost storage device. Several backup for storing. Therefore, it is more economic to lowest storage device. Okay. So information that not currently used by CPU and small very high speed memory called cache means high speed memory is called cache. Okay, that is cache memory. It's used to hold this cache memory. This one is used to hold segment of program and data currently being executed in the CPU and temporary data frequently needed in the present calculation by the CPU, thereby increasing the speed of processing by making current programs and data available to the CPU at the rapid rate. Then the memory unit that directly communication with CPU is called main memory. Okay, means this memory unit. Okay, which is directly connected to this CPU. It's called main memory. जो memory unit है वो जब CPU से connect होता है directly उसको हम main memory बोलते हैं. और cache memory I told you already now. Okay, and device that provide backup storage are called auxiliary memory, which is not here. जिस डिवाइस में बैकअप स्टोर होता है उसको हम auxiliary memory बोलते हैं. Here is not there maybe. Okay, according to the logic of the CPU, which is usually faster than main memory access time, with the result that processing speed is limited primarily by the speed of main memory. One of the important factors is that during the typical access time ratio between cache and main memory is about 1 to 7, and auxiliary memory access time is usually 1000 times that of main memory. Then how do architecture address this important gap? By putting smaller, faster cache memories between CPU and DRAM, and also create memory hierarchy. The necessary of memory hierarchy is computer system designed to overcome the following two factors, that is uh, locally of reference reuse, that is reuse, and large gap in speed, that is between CPU and mass storage device, that is DRAM. So here hierarchy of memory how it's work. Due to memory access time is that measure concern, then memory hierarchy can be achieved by using locally. Means that only small portion of main memory will be used in near future. Or it is behavior of program, which is are two types such as temporary and spatial. And so temporary, let's see, local in time. Only keep the most recently accessed data item which is closer to the processor. मतलब temporarily होती है यहाँ पे temporal, that is access data वो closer access data को ही access करती है. Keep the most मतलब वो रखती है most recently access data को जो processor के close होता है. Okay, then further data or instruction that were recently accessed are likely to be accessed in the near future. Example loops, reuse. Then spatial here only move the relevant block which consists of words to upper levels. Further neighbor of data instruction that was recently accessed are likely to also be accessed. Example straight line code, array access. Then sequential locality. Here, the basic objective in the execution of instruction follow the sequential order, which is defined in the program order, unless branch execution is encountered. For example, sequential order execute is access of large array. Then memory hierarchy here relevant heat, where the appears in block, heat rate and heat time is there in this memory hierarchy. Heat rate is the fraction memory axis found in the upper level, and heat time to access the upper level, which consists of RAM access time and time to detail time. Miss data need to be driven from the block in the lower level. Okay, so this is a memory hierarchy here. Memory unit is a one of the important unit of computer system which is required for storing the memory में जो भी unit है. Okay, ये one of the important unit है because इसमें जो भी storing program and data होता है. There are several important questions need to be addressed for any memory, such as how much fast it is, how much in capacity, how much it is the expensive, right? To answers above all question like how much fast, how much in capacity, how much in expensive. So the answer is faster memory is greater cost per bit. जितना cost होगा per bit का that उतना वो fast होगा. Greater capacity, smaller cost bit. Okay. Then greater capacity, slower axis. Going down the hierarchy, describe the cost bit, increasing capacity, increasing access time. Describing frequently accessed by processor. So there are several important characteristics are needed. Designing memory hierarchy like inclusion property, locality reference, definition, upper block address. Like upper, it is a memory closer to processor. Block, this minimum unit that is present or not present. Block address, nothing but location of block in memory. Heat, that is data found in the desired location. Heat time, it is the time to access upper level. Miss rate is percentage of time not found in upper level. Okay, so these are the comments your memory hierarchy. So to this lecture over here. Thank you.